James Clerk Maxwell is often remembered as the quiet genius who connected electricity, magnetism, and light into one breathtaking cosmic tapestry, weaving invisible threads together with the calm confidence of a master artist painting strokes the world didn't he yet understand, and doing it all with a smile that suggested he just solved a puzzle everyone else didn't he even realize was sitting right in front of them. He was born in 1831 in the rolling countryside of Scotland, where green hills undulated like giant sleepy dragon stone. Cottages clung to the landscape like tiny storybook houses, and mist drifted across the fields each morning like a gentle magical blanket welcoming a curious boy who couldn't resist asking why everything around him worked the way it did. As a child, Maxwell darted across meadows with the unstoppable enthusiasm of a puppy discovering the world for the first time. Pockets stuffed with pebbles, pieces of string, odd bits of metal, and anything else he thought might hold a secret worth unlocking, looking a little like a young wizard collecting ingredients for a spell even he hadn't quite invented yet. His favorite activity was asking questions, an endless river of questions so constant and overflowing that adults sometimes paused blinking, wondering if Maxwell's mind ran on some kind of invisible lightning while he stared up at them with wide eyes full of wonder, waiting for answers that rarely came fast enough. He loved to experiment with anything he could get his hands on, from spinning tops that whirled like miniature tornadoes to bits of glass that bent light like tiny portals to other dimensions. And he often sat at his window watching sunlight shimmer across the fields as if the universe were offering him constant invitations to explore its hidden tricks. Maxwell showed a special love for patterns, tracing shapes in sand, sketching loops and waves in chalk, and examining the world with the concentration of a detective hunting clues in plain sight, convinced that everything from rainbow colors to ripples in a pond was part of some grand mathematical story. When he wasn't exploring nature, he was tinkering indoors, building contraptions that left visitors scratching their heads, wondering how a boy could imagine mechanisms so detailed, while his family would simply shrug and say, "That's just James," as he hummed happily beside creations that buzzed, spun, or flashed in ways that seemed half magic, half science. At school, Maxwell sometimes puzzled classmates and teachers because while they were memorizing facts, he was too busy imagining how electricity and magnetism flowed like invisible rivers beneath the world's surface, sketching diagrams full of loops and curves that made adults tilt their heads like confused owls trying to make sense of them. His laughter was famous, bright, sudden, and delightfully loud, and he used it often, especially when experiments went wrong in hilarious ways, like sparks flying from unexpected places or papers fluttering everywhere as if his notes had tried to escape before he could solve them. When he grew older and attended the University of Edinburgh, professors quickly realized that Maxwell didn't just learn ideas, he reinvented them, stretching theories into new shapes, folding concepts together and asking questions so bold and unusual that some scholars wondered if he could see hidden pathways through knowledge that others didn't even know existed. He moved on to the University of Cambridge, where he walked the halls with his hands full of notebooks overflowing with swirling sketches, complicated equations, and diagrams that looked like art pieces designed by an unusually enthusiastic thunderstorm, all while he muttered ideas to himself like a friendly wizard speaking spells of mathematics. Maxwell adored light, its colors, its mysteries, and its shimmering dance across the sky, and he spent countless hours exploring how rainbows formed, how light bent as it passed through glass, and how different colors were like musical notes in a symphony the universe played for anyone patient enough to listen. He delighted in discovering that colors could be blended and separated like ingredients in a cosmic recipe, and he performed experiments where he spun discs painted with many colors until they whirled together into dazzling white light, laughing if he uncovered a secret magic trick that the universe had been daring him to figure out. But Maxwell's greatest adventure began when he set out to understand electricity and magnetism, to powerful forces that seemed invisible yet strong, mysterious yet everywhere, like cosmic twins playing tag across the world while humans tried desperately to understand their rules. He read every experiment, every theory, every scrap of data he could find, piecing together the ideas of pioneers who came before him, including Michael Faraday, whose magnetic fields Maxwell reimagined as flowing curving lines, looping elegantly through space like dancers in an endless performance. His notebooks filled with waves, spirals, and arrows that flowed across pages like the trails of shooting stars or tiny lightning bolts dancing to an unseen rhythm, diagrams that looked so alive anyone might have expected them to wriggle right off the paper. Maxwell worked for years, scribbling equations, pacing rooms, muttering calculations, and occasionally startling colleagues by laughing out loud when he finally untangled some knotty, invisible puzzle that had been hiding just beyond the reach of ordinary minds. With deep patience and astonishing imagination, he eventually realized something spectacular: that electricity and magnetism weren't separate things at all, but two sides of the same magnificent force, dancing together in perfect synchrony like partners in a cosmic waltz. He wrote down four elegant equations now called Maxwell's equations that explained how electric and magnetic fields move, interact, and create waves that travel across the universe at a speed so astonishing he had to double-check his work, then triple-check it, then laugh in amazement when he realized what the equation was telling him. Light, beautiful, shimmering, rainbow-making light was an electromagnetic wave. It was electricity and magnetism dancing through space together. It was the universe playing music made of waves, and Maxwell had found the sheet music. He stared at the result, stunned and thrilled, grinning as if he'd just opened a treasure chest to discover not gold, but the beating heart of the cosmos itself, a discovery so breathtaking it would shape all of modern physics. His theory meant that radio waves, microwaves, infrared visible light, ultraviolet rays, X-rays, and more were all part of the same cosmic family, all traveling through space like messengers, carrying secrets across the universe, and Maxwell had drawn the map that connected them. Even though Maxwell was humble and gentle, his discovery was monumental, forming the bridge between classical physics and the modern age, paving the way for radio, television, Wi-Fi, satellites, and nearly every communication technology we use today. He remained full of wonder his whole life, wandering fields with his hands clasped behind his back, humming softly, imagining invisible waves swirling around him like ribbons of energy, and smiling at the thought that the entire world was quietly buzzing with electromagnetic music. Students loved him because he spoke with warmth, humor, and joy, often sprinkling lectures with jokes, colorful demonstrations, and vivid metaphors that made even the trickiest theories feel like friendly puzzles just waiting to be solved. He believed deeply that the universe was understandable, beautiful, and full of harmony, and he treated science not as a cold, mechanical process, but as a joyful exploration of truths woven into the fabric of reality. Maxwell's discoveries became the foundation for Einstein's theory of relativity, and Einstein himself once said that if he stood on the shoulders of giants, Maxwell was one of the tallest. Today, every time we turn on a radio, send a text, watch a rainbow, connect to Wi-Fi, or gaze at sunlight warming the earth, we are witnessing the legacy of James Clerk Maxwell, the gentle Scottish wizard of waves who revealed the hidden music of the universe. His story reminds children and adults alike that imagination, curiosity, playfulness, and perseverance can uncover secrets hiding in plain sight, and that even the quietest thinkers can change the world with a single brilliant, joyful spark of understanding. James Clerk Maxwell remains one of the brightest lights in the history of science, a man whose ideas continue to ripple across time and space, inspiring anyone who dares to wonder, to question, and to listen carefully for the invisible waves humming all around us, inviting us to explore.